Hello, this is Carl from LunchboxSessions.com, and welcome to a multi-part series on troubleshooting hydraulic issues with cylinders that won't stay fixed in place, cylinders that are drifting out of position when the operator has chosen a position, wants to leave those cylinders locked, and expects them to stay there. And of course, in order to cover that topic well, we're going to be focusing a lot on components called check valves, specifically pilot-operated check valves. Look at how cool this is. You can see the components lighting up in green over on the cutaway side to match up with the symbols that I'm showing you here. And of course, the pilot-operated check valve is a topic that we first introduced in a video of ours called Vertical Cylinder Motion with a Pilot-Operated Check Valve. So look for that video. And then the first time we introduced a dual pilot-operated check valve was in a video called Directional Control Valve Basics Part 1. So you might choose to look for those videos. They'll be helpful as well. And so just as we get underway with this multi-part series, in this first part, let's just have a look at some symbol matching and some schematic reading and just understand what we've got in a typical mobile machine valve bank. We've chosen to focus on a mobile machine, a motor grader specifically, fairly modern current model. And what you'll notice, of course, if you're looking over here on the main valve bank, where the main valve spool is, this manufacturer likes the word valve stem. There is no linkage leaving the valve to connect to rods and levers and handles because this valve bank has a number of sections in it that are all operated by electrical functioning. A variable signal solenoid, a proportional pilot valve, if you will. And so, yeah, you're seeing the parts light up in green to match from the schematic side over the cutaway. So we're looking at a couple of symbols over here on the schematic where we see a diagonal arrow through a solenoid, indicating that these are variable current valves. We also see the infinite positioning bars above and below the symbol. That lets us know that this valve has a lot more to offer than just the two states shown. And in fact, as a pressure valve, this symbol is not one that's my favorite, but it shows up on schematics, so we need to understand what it does. It supplies pressure from the pilot supply, this bottom yellow line in the valve manifold. It will ultimately supply pressure to one end of the valve stem to push the valve spool in one direction, a function that would have been done by a manual lever in older designs. And then we've got the same over on the right-hand side and a passage through to push the valve spool in the opposite direction. So I'll run the cylinders up and down a little bit. And you know what you should really have a look at is the pilot-operated check valves. They're going to be very important components for us as we get into looking at hydraulic cylinders, which are involved with articulation on this particular grader. Articulation, as you know, is a function that can make the entire machine bend or pivot right in the center. That can be very important for turning or even for getting the machine to track correctly and straight while doing very aggressive grading with the blade. And there's nothing wrong with the schematic here, noticing that one line leaves the valve to the rod end of one cylinder, but to the blind end on the other side of the machine. An articulating grader pivots in the middle. One cylinder has to extend while the other retracts to accomplish that particular motion or pivot. You can see the directional valve essentially has three positions to it, even though we have some proportionality as well. There aren't infinite positioning bars drawn for the symbol above and below this main valve stem. That's what this manufacturer chose to do or to leave out. That's not a favorite thing of mine. This is a variable flow valve spool. There are metering notches cut in three places. Metering notches are usually a pretty good indicator that it is a proportional flow capable valve spool. So it might have been nice to see the infinite positioning bars above and below, but this is just how that manufacturer drew the schematic. Again, just some of the realities you live with as a technician, that schematics aren't always perfect or they're not always the way you would expect them to be, don't necessarily follow all of the rules. Now, another thing for us to pay attention to is notice on the check valves. They're using the symbol of a ball, and some check valves do use an actual steel ball. But if you're looking over at the cutaway right now, you'll see what's lit up in green is not a ball, it's a poppet. A tapered poppet and a tapered seat is every bit as popular as a ball and seat style check valve. So that's just matching up in our minds the difference between symbols and what actual parts may look like on the inside. But then also notice this. There are springs behind these check valves to help them close. You see the little green circles there when I light up the component. There are springs there. So if you were to unthread this cartridge and pull it out of the valve bank, of course, never do that while the machine is running. Make sure that you're shut down, that all safety chocks and safety links on the machine are in place, that you have depressurized. Take all precautions, please. But if you were in a position to remove this cartridge and hold it in your hand, then all of a sudden you might find that pushing on this poppet on the end, there's a spring behind it, and a fairly lightly weighted spring. And then you look at the schematic and you say, hey, I don't see the spring there. That little zigzagged pattern, that would usually be the spring. It would be right there, and there would be one on this side. But in this machine, it's a lightweight spring, and the manufacturer chose to leave it out. That's their choice. Also notice when I'm operating the cylinders up and down that there is a big piston up there near the very top of the valve, and that piston is being pushed back and forth to lift one of the two check valves off its seat. Because whenever we have these cylinders in motion, one check valve is in its natural flow direction, while the other one in blue is in the unnatural flow direction. And the only way to get unnatural flow is to pilot the check valve off the seat. So here, I'm just going to put my live schematic into the pause mode, which lets me have infinite length cylinders. So the cylinders are moving, and they're moving forever. And at this moment, that lets us have a look at the pressurized pilot line coming across diagonally here on the schematic. That's what's lifting the ball off the seat, allowing oil to return in the unnatural direction. Okay, let's go over to the cutaway. Return fluid coming back from the cylinder on the left cylinder port is being allowed through a check valve that would normally block, only because piloting is occurring over on this orange pressurized side where a bit of pressure is pushing the piston. So just maybe from about where my mouse pointer is now to the left, where it starts to push against all of the surface areas, that is what is represented by this dashed orange line. Looking over at the schematic once again.